So my name is Jarvis Wenger. I'm working with MEN as a product solutions manager. So I'm working from a concept phase of different projects all the way through a delivered product, and also supporting the life cycle of that product. Today I'm going to talk about the biggest and brightest IIoT technologies and solutions in harsh environments. I think PickMG did a good job of kind of introducing the framework of IIoT, so I don't have to build too much up to this. But one thing that always amazes me is that the human brain and how it works is extremely efficient, and it often we find that by modeling our solutions, our systems after that, or our frameworks, we produce something that's extremely efficient. And recently I've been reading a little bit about how to be more efficient, and maybe some of you have see these kinds of articles on LinkedIn or whatever, but they talk about the number of decisions that an adult human makes in a day. So from what I've read, we make something like 35,000 conscious and unconscious decisions in any given day. So that really takes a lot of energy, and in order to make good decisions, we need good information, and that's really what IIoT and the IoT infrastructure is all about. We want to make good decisions. IIoT is all about making data-driven decisions. So creating databases with our data, collecting it from whatever environment we're in, and then making decisions from that data. A lot of us here are also doing real-time decisions. So we need to make decisions in less time than any human could ever react. So it's important to also have some computing power directly where you're collecting the data. So all of this is really about efficiency, really about lowering the cost of ownership of operating a factory or an oil rig or a bus fleet or whatever you might be deploying this system into. So the ways that this saves cost and lowers the cost of ownership, it allows you to do things like predictive maintenance and figuring out when do I actually need to take this bus off the road or take this oil drilling rig down to perform some kind of maintenance on it. And of course there are other benefits of these systems, and gathering all of this data really allows us in the future, and really a lot of the future is becoming a reality now. We heard about GPU and GPU processing, machine learning, and all of that needs data. So I won't spend too much time here, but the IIoT framework, within this framework, we're kind of focused on the gateways and the edge computing, not so much the actual sensors. There's other companies that do that, and so we're really collecting the data from different places in any system that we're deploying into. We're either storing that data for a little bit, maybe performing some edge computing, and then sending it out to the cloud where it might be analyzed for additional decisions that don't need to be made right away. Some of the environments we go in to make a factory look like a relatively nice environment. So what we're talking about here is -40 to +85 Celsius. We're talking about environments where you have a lot of water, you have a lot of dirt, you have ice, you have a lot of shock and vibration. You might have a lot of EMI, EMC conditions to deal with. Some of the harshest places on Earth. So specifically, I want to talk today a little bit about the oil and gas market and how IIoT has been deployed on oil drilling rigs, for example. So here you can kind of see we have some very extreme environments. So some of these oil rigs in Canada, for example, they only really do drilling in some places from about November to February, because the the Arctic becomes a swamp unless it's frozen. So you can imagine the kind of temperatures they're dealing with in this environment. A lot of this technology that we're deploying into oil rigs is based on standards. So we have a lot of the same problems that you guys deal with in other applications. We have to support these products for a long period of time. We need it to be flexible. We need to be able to upgrade the technology to the next generation without requalifying the whole system necessarily. So we use a lot of the standards, PIC-MG, also VITA, the rugged COM Express, VITA 59, and these kinds of technologies. And they're extremely important to contain cost and to reuse these designs and make it maintainable. This is an example of an IoT, industrial IoT gateway in an oil field. So this particular application, the product serves as a gateway to the outside world. It serves as a server on the oil rig. So it's based around the conduction cooling technology that many of you are familiar with, using wedge locks, using compact PCI serial technology. There's a lot of things that are built into this and built around that infrastructure. So basically, on an oil rig, you have a lot of data being collected, whether it's from a gas analyzer or it's coming up from the drill head itself underground. And you take all of this data and you need to store it somewhere. And then you need to be able to connect to the outside world so somebody can analyze it and figure out how am I being most effective with my oil rig. And this has really enabled the oil drilling industry to lower their cost of operation. So you probably have read a little bit about fracking and the oil industry in North America. And the United States is quickly becoming one of the largest oil producers, even maybe overtaking Russia in the next year or so. And it's really been enabled by these kinds of IoT technologies being deployed onto the oil rig, because it's driven down the cost of drilling to the point where they can continue to drill when oil prices are not up at $80 and $100 a barrel. So specifically on this application, there's some additional technologies that are important. So on an oil rig, you have a generator that is generating power, but you have a lot of drilling equipment, a lot of motors. You're generating a lot of noise on this power distribution network, and so you end up with a very difficult environment for power supplies. And so uses redundant power supplies in order to maintain uptime. You might be renting the oil rig for $100,000 a day or even more, and then anytime you're not drilling because some equipment went down, you're losing a lot of money. So that becomes important. You're also dragging these systems through mud, so you want something like IP65 to prevent ingress of things that are not nice to electronics. Another application in more of a edge computing device is this display computer. So this is not the actual display computer, but it kind of illustrates the point. So this particular device is sitting in a Class 1 Div 2 environment. So there's explosive gases that might be nearby. You have a lot of electricity inside your device. You don't want it sparking and setting off an explosion. So there's a lot of certifications that this particular product has to go through. And so what VITA 59 allows us to do here is to focus on engineering the housing and the infrastructure to prevent those explosions, to operate in that environment. And the core computing power of that device becomes MEN's problem, or becomes the computer supplier's problem. So this particular application is interesting because they're collecting data, they're deploying sensors and collecting data in an environment that is very extreme. So there's actually sensors, companies that produce sensors that are operating at the drill head. So they might be a mile or so underground away, and they're controlling the drill head. They're figuring out what direction do I need to go, what kind of rock am I drilling through, and that kind of thing. So you end up with a lot of data coming back. You're able to control it. You're able to slow down the drilling. If the rock becomes more dense, you want to keep your drill from being destroyed. And so again, all of that data allows you to do things that weren't possible before. We solve several problems with these standards, and by deploying IIoT on oil rigs, we provide a robust solution in a tough environment. We provide high computing power, and we create solutions that are scalable because we can take one computer out, one processor generation out, and put in a new generation. And of course, you make the life cycle management easier for the same reasons.